Hi, welcome to clickmyproject.com.
Let us see the abstract of Bootstrapping Ontologies for web services. What is meant by Bootstrapping Ontologies? Ontology is a formal, explicit specification of a shared conceptualization. Ontology is used to make knowledge sharing and reusing easier. The abstract is, ontologies have become the de facto modeling tool of choice, employed in many applications. Ontology bootstrapping, which aims at automatically generating concepts and the relations in a given domain. Bootstrapping an ontology based on a set of predefined textual sources such as web services. In this paper, we propose an ontology bootstrapping process for web services. The WSDL descriptor is evaluated using two methods, namely term frequency, inverse document frequency, that is TF-IDF, and web context generation. Our proposed ontology bootstrapping process integrates the results of both methods and applies a third method to validate the concepts using service-free descriptor. Let us see the full process of our project. First process, WSDL. WSDL extension for web services description language. It is an XML-based language used to define web services and describe how to access them. WSDL describing network services as a set of endpoints operating on messages. It's containing either document-oriented or procedure-oriented information. Next module is token extraction. In this module, we develop the token extraction process using WSDL. WSDL document with the token list bolded. The extracted token list serves as a baseline. These tokens are extracted from the WSDL document of a web service whois. Next process is web context retrieval. In this module, we develop the web context retrieval process, where the web pages clustering algorithm is based on the concise all-pass prefilling clustering method. This method approximates prefilling of large classifications. It compares all classes pairwise and then minimizes the total number of features required to guarantee that each pair of classes is contrasted by at least one feature. The next process is TF-IDF ranking, term frequency IDF analysis. TF-IDF, that is TF-IDF, term frequency inverse document frequency analysis is made in this module. TF-IDF is applied here to the WSDL descriptors by building an independent corpus for each document. Irrelevant terms are most distinct and can be thrown away with a higher confidence. To formally define TF-IDF, we start by defining frequency as the number of occurrences of the token within the document descriptor. Next process is concept evocation. Concept evocation identifies a possible concept definition that will be redefined next in the ontology evaluation. The concept evaluation is performed based on context intersection. Next process is ontology evaluation. Ontology evaluation is the last module where the descriptor is further validated using the textual service descriptor. The analysis is based on the advantage that web service can be separated into two descriptors, the WSDL description and a textual description of a web service in free text. The WSDL descriptor is analyzed to extract the context descriptor and possible concept as described. The ontology evaluation consists of 4 steps, including building new concepts, determining the concept relations, identifying relations and types, and resetting the process for the next WSDL document.
Let us see the full demo of Bootstrapping Ontologies. This is the home page for our project. Now we can load 2 files for clicking the load data button. Now the two files are loaded to our text area. One file is WSDL and another one is XML file. It's containing special characters and tags. Our next process is removing the special characters and tags. So we want to go next page by clicking the arrow button. Now we need to click tag removal button for removing special characters and tags. After clicking the button, two files are containing only alphabetical characters. Now we want to go next page by clicking the total words button. Our next process is counting the total number of terms presenting in these two files. The total term button is used to counting the total number of terms. It also displayed the total number of terms and number of documents to be loaded. Next we move to next page by clicking the term count button. Now the two documents are combined in a single text area. Our next process is counting the individual term count. That means counting each word occurred by number of times. Simply each word present in number of times in the document. The term count is used to count the term occurrences and displayed in a list box. For definitions occurred only one time in the document, but the name occurred 11 times in the whole document. Now we move to next page by clicking the term frequency button. Our next process is calculating the term frequency. The term frequency is calculated by each term for using term count divided by total term count and displayed in a grid view. Next we clicking the document frequency button. It displays the document frequency in each term. The document frequency is calculated by term count divided by document count. Now we clicking the IDF button. It displays the inverse document frequency in each word. It is calculated by document count divided by document frequency. Now we move to next page by using the TF-IDF button. Our next process is calculating the TF-IDF. The TF-IDF button is displayed in the term count, term frequency, document count, total term count, document frequency, IDF and TF-IDF. The TF-IDF is calculated by term frequency multiplied by IDF. Now we move to next page by clicking the context retrieval button. Our next process is retrieving the context ID by clicking the context retrieval button. It displays the context ID and its value type. Now we move to next page by clicking the concept evocation button. Our next process is concept evocation. The process is done by clicking the concept evocation button. Now we move to next page by clicking the ontology button. Again we want to click ontology button in this page. Now the final output will be displayed in the XML format.